Welcome to this course on computer vision, CCS 338, professional elective for 6th semester. Okay. What is meant by computer vision, or what do you think is computer vision? You have all opted for the professional elective computer vision. Can anyone tell me what is the most interesting aspect of computer vision? So in this lecture, what I'm going to do is that I'm going to give you an introduction for why you have to opt for computer vision, or what is meant by computer vision. Okay. First thing you have to understand is that all what we are going to study has a great influence with several machine learning, deep learning algorithms. Computer vision is an advanced topic, highly useful, highly area of research where there is a huge amount of scope for your professional development. So this time, when all our teachers were meeting in the computer science department, there were so many questions asked about which subject who is going to take, or how we are going to do the subject allocation. My first preference was always computer vision. You know why? See, computer vision is the area where you can do infinite amount of projects. There is a huge amount of scope. See, when you take, say, for example, one area where computer vision is applied is robotics. There is a difference between eyesight and vision. There is a difference between sitting inside the class and attending the class. When you sit inside the class, you may sometimes sit simply dreaming of something else but not listening to the class. But when you are attending the class, what happens is that you are understanding whatever is the lecture speaking about. You are able to get in depth about a concept. So seeing is different, vision is different. You understand the difference between what is simply seeing and what is meant by vision? All of you? So here we have the topic or the domain as computer vision. One example I told you, robotics. Similarly, there are infinite applications like, see, unmanned vehicles, drones, object detection. You know what is object detection? When a drone is flying, when it sees an object, it detects and it moves out, right? So, what happens when this drone is able to see that particular object? It has to sense the area, it has to sense the length, or how far it has to change from the original place. Am I right? So computer vision deals with all these kinds of problems. And computer vision will be a very, very, very interesting subject for you, and like many other subjects. Okay, so that's the importance of computer vision. So I will show you an image. So you can see this image here. What is this image all about? What do you see from this image? A cycle, flowers, pots, doors, windows, and so on, right? Next slide, I'm going to show you how a computer is going to see the same image. So this is how a computer sees this image. What is this actually? This is a set of matrices, full set of numbers. Okay. If you see the previous image, you could see that there would be so many drops, there would be so many grayscale, so many colors. Each point is called as a pixel. The smallest point in an image is called as a pixel. So what is a pixel? What is a pixel? The smallest point in a computer graphic image. The smallest point, it will be having one particular size. So each pixel will be having so many attributes. We will be having different kinds of colors, size, mean the level, grayscale levels, and so on. We'll see about that in depth as we go on. So each of these things are represented by numericals or numbers or matrices. Your computer is capable of seeing an image as only as matrices and numbers. For each value will have some significance for that particular number. So now I'll give you some examples. So this is an introduction class. I'm giving an introduction to the course as such. So here I will be covering up all the 5 units, basics of 5 units. So what we are going to study in the next 6 months? What will be the contents of your course? Okay. So here I'll give you some examples as an introductory session to the course. I'll give you some examples of certain kinds of algorithms that we need or we use in computer vision. Please note the first image. You can see that there are so many. Let me take some laser. You can see that there is an algorithm that is detecting so many faces. Face recognition, right? You have a person here one, a person two, person four, and so on, right? Yes or no? This is an algorithm for face recognition. Similarly, we have another image on the right side that is able to classify certain images or certain parts of this image. Yes or no? So you have two images. What are these two images? We'll see what are the basics. What is the see? The first is the face detection algorithm, coupled with color-based clothing and hair detection algorithms. These are all some examples of the algorithms that you could develop. See, this subject or this course is a theory cum practical course where we will be learning some kind of practical applications using certain Python packages also. These programs I'll be sharing with you. You will be having your observation record and marks and everything for that also, as usual. Okay, so first one is a face detection algorithm. So we supposed to do this kind of face detection algorithms in practice in our lab. Okay, and we have this color-based clothing. I would like a system, a computer to find out how many of you are wearing red shirts or yellow shirts. The method through which we identify how does what is the logic behind this identification? How can a system determine how many students are here with red color shirt or yellow color shirt or so on? How will you determine that? We learn about different algorithms that are used for identifying color based clothing or something like that. Hair detection algorithms. Okay, how many of you are having long hairs, or how many of you are having no hairs, and so on. All these things can be determined by using some kind of algorithms. Object instance segmentation. See, most of at the time of Operation Sindoor, you might have noticed that you might have received so many WhatsApp or other videos where a drone is flying and another drone is attacking this flying drone. It is capable of exactly catching this drone and spoiling this its attack. Have you seen that? How many of you have seen that? A drone is flying, another drone which is going to neutralize this drone. This drone is a bomb. Another drone will come and neutralize this drone. You have seen these videos in defense applications. You have drones where one drone is a carrier for dropping bombs. There will be another drone which is going to neutralize the effect of this drone. So you need to know the precise location, you need to find out the object, you need to track the movement of objects. You need to track the movement of objects. That means a thing is moving and your system or your algorithm should be capable of determining after 5 seconds or 10 seconds or 1 minute where this object will be. Right? So these are all the extremely interesting, beautiful area where we are going to study. We are going to do some practice, we are going to do some lab, and so on in our computer vision course. Okay? So what is the objective, basic objectives? What as of now will be, I have some projects in robotics also. I've been inviting some students to come forward. On So what are the objectives or how we can define the need for computer vision as a separate branch of study? Why should we study computer vision as a separate branch of study? What are the goals? You see an image, every image tells you a big story, right? When you look into it very carefully, you can see that every image has something or much more to tell about it. So, computer vision is not simply getting this image into numbers. Computer vision is something wherein it has some kind of intelligence in it. It is able to analyze the image. I told you an example now. A drone is flying, an object is there. The drone should be capable of understanding that this object will hit him and he has to move and go away. So, a machine learning or a deep learning algorithm will be designed in such a way that an image is analyzed. Analyzed in another, what do you mean by analyzed? You understand the meaning of the image. So in computer vision, what we are doing is that we are not simply seeing an image. You are not simply sitting inside a class, but you are attending the class. That means you are able to understand what your lecturer is speaking. Right? Sitting inside the class and looking outside or dreaming about your girlfriend or boyfriend, you will forget everything, you don't learn anything. Am I right? So here, you are not simply looking at the image, you are able to understand the meaning of the image. You are not simply sitting inside the class, but you are able to understand in what sense a lecturer or a teacher is speaking about. That is called as computer vision. That is the objective of the study. So here we are perceiving the story behind the picture, and world for us is, for a computer vision, is what a camera can see is the world. The area around it or the environment. We use the word world very often. World means it's a small space where we are going to see that, not the exact English meaning of world. Okay? It's not the exact English meaning of the word. World here means that the area where you are going to watch, where you are going to see, you are able to understand. Okay? So the objective of computer vision, goal of computer vision is to perceive the story behind the picture. So it can compute 3D shape, names of peoples or objects, or for example, what is that? That has happened. Okay? So we have discussed about the goal of computer vision and what are the things that we basically do with computer vision. We analyze the shape, 3D shape I told you, name of people or objects. What happens? See how if you are using Google Photos, you can see that if you type any keyword, you will get all the images related to that keyword. For example, you type dog, you will get all the images which is there in your Google Photos drive, which is only dogs, right? So how does the computer or the system find out whether an image contains a dog or not? You might have seen that. Find out how many of these images do have traffic lights. Very often, very commonly asked question to check whether you are a human being or a robo, right? How many of you have seen that very often? There will be 4 or 5 images and you will be asked to check out the images with traffic lights so that the system can confirm that you are not a robot. So it's identification of objects. Next question is that can our algorithms match human perception? So what is your opinion? The way you analyze, can computers do it? Can algorithms do it? What do you people think? Whether we can develop algorithms better than human beings can do? So can our computers match with our human beings? What is your opinion? In general, see some of these slides are taken from a website which I have given you the link in your Google Classroom. Okay, the textbook for this is available free of cost. You can download that in PDF format. The link to download is given to you in your Google Classroom. I want all of you to download the original textbook. Okay, all the materials are already posted in Google Classrooms. Clear? And what is this image telling about? Can anybody tell me? Black and white image, that's fine. That can be easily identified by a computer or anything. What else this image is talking about? This image, what else is it talking about? Yes? Accident, very good. Anything else? The next slide, I'll tell you what this image is all about. Okay. But of late, in the recent times, there has been a lot of research going on with respect to making computer work like how human beings work and think. We have deep learning algorithms, we have deep reinforcement learning algorithms, and so on. The very interesting subject, lot of progress is happening, lot of research works are happening, and lot of projects are available. In the upcoming semesters, you will be having project works and internships which you are supposed to do. wherein this is the most prominent domain. Without computer vision, it's very difficult for you to complete a intellectual project or something that is related to your academics. Okay? So what this image is telling about, we'll see what this image is telling about. What is this original image? There is a small clue given in the text. So in this picture, we have a famous derailment accident that took place in 1895, wherein in Paris, the train had overspread, broke the buildings, and came out. Okay. So the details of that image is given in this particular slide. This can be read and you can share it also. You can understand more by reading this. The question here was, now, why did I post an image? Why did I post an explanation for that? Why should I do it? Can anyone give me the answer for me? Why should I do this? Now let me ask you one question. Can you develop an algorithm in which this image is given as the input and the output is given as this particular text, whatever is written here? Is it possible? Think about it. I'll give you some case studies wherein you can work about all these things. In one of the previous slides, I showed you an image, right? Like this. And then I asked you how you are seeing it and how a computer sees it. Computer has so many numbers in it. And you see flowers, pots, you see cycle, you see windows and so on. So here I'm giving you another similar image. And one of the goals of computer visions I'm going to explain with the help of this image, this one and the next slide. One type of algorithms, what we do with computer vision is classification of objects or identifying different parts of an image which contains different things or labeling the parts of image. This is called as labeling the parts of an image. Say for example, this is an example I'm giving you. This is also taken from a very world famous book on computer vision. So it's this credit I mentioned here. The name of the book, you can go to the website and search for it. So what we do here, we say that this is a building, we say that this particular thing is a face, this is a street lamp, bus, banner, flag, cars, and what. So we will be writing algorithms wherein we take input image like the one that was there in the previous slide that gives you an output image where the image is being where the different components of this image is being identified, whether it is a building, whether it is a flag, banner, face, bus, street lamp, cars, wall, or anything else. Okay? So I believe that I've given you a brief introduction about computer vision. Is there any questions? I'm open to questions. You can ask me anything related to this computer vision, why you should study computer vision, why you have chosen computer vision, or what are the things that is there inside this. Now next, I have five more, I have 6 slides, 5 more slides. Each slide will give you each unit, the 5 units that we have to study in this semester. So introduction is over. Now I'll be teaching you, I'll be telling you what are the important topics or points in the syllabus that you have to study. So next few slides will be only explanation of syllabus. So as far as now, is there anything that you want me to answer, which I can answer for you right now? You can ask me. I would enjoy more interactive sessions. I presume no more questions. Next 5 slides will be done very fastly because the text as such is being shared to you as PDF and so on. So far we have studied so many courses. Now here I'll be giving you the course with the course objective. What is the objective of the course? That means that what are the things that you can do after you have completed this particular unit or particular course outcome. Okay. So first one is that you have to understand the basic knowledge, theories and methods in image processing and computer vision. Image processing and computer vision. We have so many interesting things that we need to do about image processing. We need to find out how to analyze an image. First thing is that you need to understand what are the components of the image, right? So what is the first course outcome? Basic knowledge, why we are studying computer vision, what is computer vision, how image is being represented, what are the image analysis tasks, and how to digitize an image, properties of an image, data structures. These are all important areas where you need to really concentrate on, right? You have huge scope for research activities. Different levels of image representation, traditional and hierarchical image data structures. So, for your internals and external examination, keep in mind your course outcome. If you are asked to tell what is the outcome of the course, you should tell because your questions will be drafted based upon how much you have learned out of each unit. So, course outcome is important. You need to understand what is course outcome. Based on your course outcome, you will have questions. The unit 2, to implement and there's something missing here. To implement basic and some advanced. No. Basic and advanced image processing technique in OpenCV. This unit will be mostly practical. Your experiment will be given. Your first experiment is about OpenCV, how to install and work in Python OpenCV. OpenCV is a library in Python like NumPy and SkyPy and other libraries which you have already studied. Okay, OpenCV is a library for computer vision. So feature detection, like we have seen now, I've told you what are the features, matching and segmentation and so on. So when I give you 2 fingerprints, okay, can you develop an algorithm to see whether these fingerprints match or not? I give you a sample. I want to say, for example, I told you the color identification, color detection. Similarly, I want you to write an algorithm to find out how many people are wearing t-shirts and how many people are wearing shirts. What kind of algorithm you will think about? You have t-shirts with collars also, right? What differentiates a t-shirt? Maybe the buttons or something like that. You can think about that. These are all feature detection techniques. We'll see that in detail. We'll see with examples. We'll see with case studies. So I assure you that this part of this course will be very, 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 very interesting. Because 90% of the things what we are going to do is we are going to do in practice. Course outcome 3, to apply 2D, we have 3D also, right? We have to apply 2D, a feature-based image alignment, segmentation, and motion estimation. From images, we are going to move towards videos. We are going to say robotics, the robot is walking, it has to keep the distance analysis, right? A bullet you are shooting, right, is coming towards you. You should know the distance at which it is going to strike something, right? So, motion analysis. This is the course outcome 3. I want you all to read the course outcomes very clearly so that it will help you to write your exams much better way, because examination results are also a part of your outcomes. Outcome means what you have really learned or what you are expected to learn after completion of each particular unit. So this is what we are going to do. Clear? Is that okay? These areas you don't need to note down because this is shared already in your classrooms and other. It's there in my drive also. There's a fourth unit. From 2D, we are moving towards three-dimensional image reconstruction. These are some examples which I'll be showing you. Very interesting things are available. I'll come to that one by one. So this is the fourth unit, what we are going to study. Okay. Fifth unit, image-based rendering and recognition. We have seen some examples like face recognition and so on. So I'm not going to go into the depth of these topics. This is just to show you what are the topics that we are going to cover in the next 5 units. So with this I come to conclude our first lecture, first session on computer vision. I am open to questions. I am open to doubts regarding anything within the course or beyond the course. I'm very happy that the whole class had opted for this subject. And I'm very happy to guide you for future projects and research. A course is not completed once you have passed the exam and you got the results. A course is completed only when you are able to apply what you have learned in your real-time applications. Otherwise, there is no meaning in studying. What you have studied should have been converted as a document, as a research document after you have done so much of work beyond what is being taught in the syllabus. So this is a very beautiful uh, area where you have good scope for development. This is for individual personal development also. Personal development for me also, for you also. For everyone, you will learn more, you will apply things, you will do research, you will come up with that. So any questions? So thank you all. Thank you very much. I'm winding up this session. Thank you.